I've been reviewing geometry the last couple of weeks, and the issue here is that we have no figures in geometry. There are no true, genuine figures in geometry. Why is that important for the subject of today? Because I'm going to be talking about black holes, and the question is whether the black hole is a geometric figure. You might say, "Well, Bill, where'd you get that? I mean, wasn't it a star that collapsed on itself, by gravity and gravitational collapse?" Yeah, but what do you end up with? You end up with a point in the center of what is known as an event horizon, which is, like this volume or this region that surrounds that center, that point in the center. And so we need to know what a point is, because that's what a black hole is. It's a point. And you say, okay, what is a point? Well, we already covered that. A point is a location. It's not a geometric figure. Okay, it's a location. And for hundreds of years now, we've been fooled into thinking that we were looking at a geometric figure that is always represented with a dot. Could be typically it's a two-dimensional dot. Just you hit the pen against the paper and you're looking at it as a two-dimensional thing there, right? And some people say, well, it's got some relief, yeah. So you can say it's three-dimensional. But the point here is that when you have a little dot on a piece of paper or a chalk mark on the board, we think of that as a two-dimensional figure. Think of it as a circle, okay? But a circle is two-dimensional. And so the question is a dot two-dimensional? Well, a dot is a two-dimensional figure, but that's not what a point is. The point is this dot, this two-dimensional circle that represents what? A location. So the point is really a location, and that's what the geometer is going to work with. He's not going to work with a dot. He's not going to work with a circle. He's going to use those as pictorial representations of this abstraction known as location. Okay? And in mathematics, they call it position because they designate it, for example, with an ordered pair, the most common one, Cartesian coordinates. Could be a triplet, etc. So what is a point? We're talking about a location of a location on something. So if you have a wall, if you have a ball, if you have a cube, whatever you have out there, the dot represents a location, pictorial representation of a location on this cube, on this circle, on this wall, on whatever you put there. Okay, so that's how it works. And so it represents a location, but then the question is, if it's a location, why didn't the Greeks, who invented all this stuff for us or served it in a gold platter to us, why didn't they just call it a location? I mean, if what they're going to be using is a location, call it a location. Why call it a point and mislead you to believe that they're referring to a geometric figure such as a two-dimensional circle, a plane, and call that thing a zero-dimensional point when they really mean non-dimensional location. Okay, we see how this gets confusing, because then they'll tell you, well, we cannot define the point. Well, of course you can't define the point, because you're using the dot of physics, which is an object, it's a figure, it's a two-dimensional figure on the one hand, but then you're trying to define it as a zero-dimensional what? What is a zero-dimensional whatever? You're talking about a concept. And what's the concept? Location. Okay? So we get to the issue where we get here, where we're going to build the line, the next geometric figure. We call it a one-dimensional line, and it looks more or less like this. It's just a string of locations. And what they're talking about is an itinerary. Okay, that's what it is. So you say, well, if these are the foundations of mathematics, okay, the question is, how rotten is geometry? It looks like you built your building on quicksand. Okay, because look at the foundations. The foundation is the dot, which is a location. It's represented by that ball or two-dimensional plane, circle, whatever. And then they put another two-dimensional figure, which is an elongated rectangle, very elongated rectangle. It's obviously two-dimensional. Both of them are, because you can see both of them. You can't see anything below 2 dimensions. And what is it? They're talking about locations. What is a 1D line made out of? One-dimensional line made of? Zero-dimensional locations. What are they talking about? They're talking about one-dimensional something? No, they're talking about a series of locations. They're talking about an itinerary, a trajectory, maybe an orbit if it's curved. Okay, so that's what they're talking about. That's what a line is. That's how it's defined. But then they put a little stick and they say, see, that's the line. No, that's not the line, because they have no use in mathematics, in geometry. They have no use whatsoever for that stick or for that little ball. They have no use whatsoever. They're going to be doing math. They're going to be doing angles. They're going to be talking about parallel and perpendicular. So they have no use for these geometric, the figure itself. Okay? They have no use for figures in mathematics. And that's what geometry is today. It's just a bunch of relations that tries to unite mathematics with physics. In fact, it's the origin. Geometry is the origin of so-called mathematical physics. Mathematical physics is a contradiction in terms. It's an oxymoron because you have math, which is a language. It's a language that can only describe. And you have physics. Physics deals with objects, and the purpose of physics is to explain what? Mechanisms. Never the twain shall meet. You cannot merge physics with math, math with physics. And this is the problem here, because geometry tries to merge math with physics. And you say, well, okay, we need to establish relations, we want to do measurements, we want to come up with calculations and equations. Yeah, fine, leave that all within math. Don't bring it into physics. In physics, we have to explain how Mother Nature does her stuff out there. We need to know how she does gravity, how she does light, how she does atomic behavior, quantum jumping and that kind of thing, or magnetism and electricity. That's what physics is about. That's what we want. That's what the ordinary person out there wants to understand. He doesn't want to do math. He doesn't care about math. That's why physics has become so unpopular among people. Nobody cares about it because all these people come in there with math and with abstract concepts, new concepts they invent every day with words this long, and people say, I don't want to deal with all that. You guys deal, you're the experts, you deal with all that. Just give us the bottom line. And the bottom line are the physical interpretations. And what are these people saying? They're saying nonsense. They're saying a particle could be at two places at once. They're saying there's a physical object called space-time out there. They're saying there was a big bang, an origin to matter. Even though they're atheists and they don't believe that there's a God that created the universe, they do believe that there was a moment of creation that matter came out of what? Out of nothing, or energy, or whatever they want to call it. So they have all these ridiculous, irrational explanations on the one hand, which they serve to the public, and the public believes them simply on the basis of authority because nobody wants to deal with the math. And so, yeah, physics has become a very unpopular thing. Nobody does physics out there. Nobody cares about it. It's just the specialists who deal with physics, and they're all brainwashed in the same way at the universities. Otherwise, they don't get the degrees. They don't get an advisor. And what do they talk about? Well, they talk about the nonsense. Nonsense such as what? A black hole. Okay? That's the kind of nonsense they talk about, black holes. And yeah, people say, whoa, we took a picture of them. Well, I'll get to that in a second. Anyways, here's the famous circle. Okay, and again, that's an orbit. I talked about that in the past. Okay, here's the cube. Okay, and what is a cube? Is a cube a solid figure? No, it's a hollow. It's made out of all these points. Okay, so the question is whether that is a 3D object or it's a bunch of locations. Are we talking about a perimeter? Is that what we're talking about? In which not even the ones in the center are there because it's like they look at lines, and so it's like they have a cube made of lines that go from corner to corner, and it's essentially a cube is a six-sided window, or six windows on each covering it, and it's got no window pane. There's no glass in it. Okay, so it's just the lines. And in this case, this is another version. It's just a bunch of points. So the question is that what a cube is? Because this is a hollow, not a cube, okay, and not a solid. Okay, so what is the problem with all this? The problem is that, again, they're going to extrapolate all these notions that they have in geometry. They're going to extrapolate them into general relativity. General relativity, what is it? It's a geometric theory of gravity. Geometric theory of gravity. I didn't say that. These people say it. I'm just repeating it. I'm just regurgitating what they already said. It's a geometric theory of gravity. They're going to explain gravity as being a geometry of space-time, the warping of space-time, the bending of space-time. What are they bending? They're bending time. They're warping time. Not facetiously or even figuratively. They're saying literally. They're warping time. Okay, so why doesn't the Earth fly out of the solar system? Because there's a warp wall of time that comes in contact with the skin of the planet. Okay, that's what's happening here. And because they have to explain why the Earth doesn't fly out of the solar system. And you say, oh, what prevents the Earth from flying out if it's swinging around the sun? And so, we say that every atom of the Earth is tied to every atom of the sun. We have a physical entity holding the Earth. Now we see why the Earth doesn't fly out of the sun. We have a mechanism that is valid. What is their mechanism? Their mechanism is not that the Earth is connected physically to the sun. Their mechanism is that there's a roulette kind of thing, and our Earth is a little ball that rolls around this roulette. So the skin of the Earth is coming in contact with space-time, with warped time. And so they're saying that warped time is what physically prevents the Earth from flying out of the solar system. That's their explanation. That's their physical interpretation. And of course, when you throw this in their face, they say, well, you're not supposed to take the analogy literally. That's their answer. You're not supposed to take the analogy literally. You got to take math, they say, to understand what we're saying. We want to know the physical interpretation. We don't care about your stupid math. That's the answer to you. We want to know the physical interpretation. What prevents a solid object such as the Earth, not solid completely, but I mean, it's quite solid, right? It's a rock. This rock, this roundish rock, rolls around the sun. What prevents this rock that we know is here because we put our feet on it, what prevents it from flying out of the solar system? What prevents it from flying out? And these people are saying warp time. And then when you put them against the wall and say, well, what do you mean warp time? It's a concept. They say, well, you're not supposed to take the analogy literally. You got to take math to understand. That's the answer. So yeah, we have irrational explanations, and what people want to know, if we can bring them back into physics, is the mechanism. That's what people want to understand. They don't want your equations. Okay. So what happens? It turns out that a black hole, is a what is it? People are not aware that it's a zero-dimensional entity. Yeah, it's a zero-dimensional thing. And you say, what do you mean a zero-dimensional thing? Then let me show you here. These are comments that people make. Oh no, let me first start with this. I want to cover this first. So what does a mathematician do if he wants to give you a physical interpretation? Like I just said, why doesn't the Earth fly out of the solar system? Well, I'll give you an analogy. I like this analogy, that's why I don't want to skip over it. You see a hole in the wall. Okay, you see this, okay? This is what you see on the wall. And you call the expert of math and you say, okay, tell me how that hole was made. Hey, can you explain that? And the guy comes in there with his ruler, whatever he brings in there, his calculator, and he measures and he does all his experiments that he needs to do, and he calculates, he comes up with an equation, and he says, yeah, I can tell you exactly how that hole was made. Okay? And this is what he proposes. He proposes that it was made by a unicorn. That's what he tells you. Say a unicorn, but hold it, unicorns don't exist. What do you mean a unicorn? And the guy says, well, yeah, you're not supposed to take the analogy literally. What do you mean? I mean, you're giving me an explanation how the hole was made. You're saying it's a unicorn. I'm telling you that unicorns don't exist. And your answer is, well, you're not supposed to take the analogy literally. That's the kind of answer you get from these people. And so here's a black hole, okay? Because they talk about them in these conferences. They talk about their equations, all that fancy stuff. And they even took a picture of it. Here's a picture of it. Isn't that fascinating? Look at that. Look at that picture. Beautiful picture. So what the hell are we staring at? Are we staring at a black hole, as they say? Actually not. What you're staring at is, according to them, okay, matter falling into a black hole. Remember, a black hole is zero-dimensional, and a lot of people have trouble with that. In fact, when I had my talk with Garipi, a fellow in Canada who has a show, I told him that that's what a black hole is. A black hole is zero-dimensional. And he said, well, no, that's not true. And so I showed him evidence, and he still did not believe me. I didn't create the evidence. I was just putting out what the experts out there say. And he still refused to believe that a black hole is zero-dimensional. Because if you can show to anyone that a black hole is zero-dimensional, and they actually come to grips with that thought, with a notion that a black hole is zero-dimensional, it's just a location with nothing in it, it's just infinite density because it's got all this mass and zero volume, so you got infinite density. And so what is a black hole? Well, if it's zero-dimensional, it's not much of anything. That's what it is, a point. It's a geometric point, which is what? A location. And this location is surrounded by what? An event horizon, which is, the best way I like to explain an event horizon is that, campfire. You put a campfire and the heat, has a certain distance. After a while, if you move far enough, you won't feel it. You'll be cold. You'll be out in the cold still, right? It's like the heat doesn't reach you. But the closer you get to the campfire, well, there's this radius in which there's still heat. And that's more or less what a black hole is. The region of influence of a black hole at the velocity of light in which it overcomes the escape velocity, as it's called, that reaches up to the event horizon. After that, They're pretty much scot-free, you know. And so it's a zero-dimensional location, infinite density, that's surrounded by a region of influence of which the perimeter is called the event horizon. That's more or less what a black hole is. So far we have nothing in front of us. It's just abstractions, mathematical abstractions. That's all we have. We don't have a physical object. For example, we don't know why or how a black hole would be able to influence a star that is a few light years away. How would it move it around itself? By what physical means? That's the question. And you cannot use the word mass and say, well, it does it through mass or gravity. Those are concepts. We need to know what physical entity is in contact, physical contact with that star. And that's where we lack in understanding, because these people are not putting a physical object between the black hole, which is already not a physical object, and the star. We need to know what's connecting them physically. Is there a connection or not? And what they say is, you know, the black hole warps space-time, and again, we get to this issue where they're warping time, and that's what's compelling the star to move around like a little ball around the roulette. That's the answer. So the first thing I want to establish is that a black hole is zero-dimensional. For those of you who have a little mental capacity to understand, a black hole is zero-dimensional. Is that what I say? No. I'm going to put evidence from the, gurus, from the head honchos of general relativity. Okay? If you don't believe them, I don't know who you're going to believe then. You don't have to believe me. I'm just going to put their testimony so that you understand what these people are telling you. Hopefully you're opening your eyes, your ears, and listen to what these people are saying. Okay, here goes the first one. First testimony. We called to the witness stand Mr. Stephen Hawking. Okay, I hope you understand who he is, or remember who he is. He died a couple of years ago. He wrote a book called A Brief History of Time. What is it? I think it's 87 or 78. It's 87. Okay, 1987. And he says the following, and this has to do with Chandrasekhar, who won the Nobel Prize for demonstrating that a black hole is zero-dimensional. He proved it mathematically. Okay, let me repeat that because some people haven't heard that yet. Chandrasekhar proved that a black hole is zero-dimensional. He proved it mathematically. Okay, we got that? And I'm just repeating what this man's going to say now. He says, Chandrasekhar calculated that a cold star of more than about 1.5 times the mass of the sun would not be able to support itself against its own gravity. 1.5 times the sun collapses to, it can't support itself against its own gravity. What does it mean? Would it collapse to infinite density? What is infinite density? It means no volume. That's what infinite density means. No volume. You can put as much mass as you got. It doesn't matter because if you have no volume, you've got infinite density. You're dividing by zero. Okay, that's essentially what it is. Eddington was shocked by that implication, and he refused to believe Chandrasekhar's result. Arthur Eddington was Chandrasekhar's supervisor, his boss. And he said, I'm not going to let you publish that nonsense. You're not going to ridicule the mathematical establishment. So he was dead set against that. And not only him, as we'll see, also Einstein, who was a big man by the time, right? Eddington thought it was simply not possible that a star could collapse to what? To a point. What was a point in geometry? A non-dimensional location. That's what a point is, okay? Einstein himself wrote a paper in which he claimed that stars would not shrink to zero size. What did Einstein say? That it was not possible for a star to shrink to zero size, no radius, no diameter, no circumference. I hope that's clear. I mean, people then say, no, they never said that. Here you have it. Everybody's talking about zero size, infinite density, etc. However, he was awarded the Nobel Prize, Chandrasekhar, in 1983 for his early work on the limiting mass of cold stars. Chandrasekhar had shown that the exclusion principle could not halt the collapse of a star more massive than the Chandrasekhar limit. He proved mathematically through an equation that a black hole is zero-dimensional. A star that is bigger than the sun, so many times bigger, it doesn't matter, collapses to zero size. I think it's clear. Okay, but some people say, well, that's poor old Hawking. He's not around anymore. He's got no authority. Okay, let's bring some more proof, evidence. Okay, people need authority to believe, so let's make them believe. This is a black hole. So you can see it's zero-dimensional. What does a black hole look like? Like that. It looks like zero-dimensional nothing. Okay, so here's another testimony. This fellow's name is Chaudhry, and he wrote a book and published it at the Cambridge University Press. Okay, so he was a teacher, a professor for many years in different universities. Okay, so he's not a nobody, he's a somebody. Okay, not the biggest somebody, but certainly a guy who was specialist in this kind of subject matter in black holes. It says, on solving the equation with a particular value rho of central density, you will get a model of a star with mass m and radius r. Okay, plot r, radius, as a function of m, mass, right, and show that r falls to 0. Falls to 0 when m is equal to the Chandrasekhar mass. If you can do all these, then you have repeated the calculation for which Chandrasekhar won the Nobel Prize. I hope you understood all of that. If you have 2 fingers worth of brain, okay, I'm sure you can understand that. They're talking about zero size. Okay, you still don't believe. We'll bring Mr. Harrison to the witness stand. We'll have him testify. He's a professor at Toronto University. Many years. He's prominent on the internet. And you can visit his site. His name is David Harrison. And it says, if the mass of a star is greater than about 3 solar masses. Here we're talking about 3 solar. The other guy said 1.5. Okay, fine. It goes through the neutron star stage and keeps collapsing. In this case, the gravitational attraction is so intense, the neutrons are literally, what? Crushed out of existence. Crushed out of existence. They turn into empty space, into nothing. That's what he meant. We call the object a black hole. I hope everybody understood. Straightforward. I characterize a black hole as an object whose gravitational pressure is so intense that the matter of the object, again, is crushed out of existence. And then he goes on to make a calculation for the Earth and saying, well, this is, if we could crush the Earth to such and such size, then we would get a black hole. And again, he says, the issue is that if it's got enough mass, it can continue to collapse until there is no matter in there. There is no structure. There is no nothing. There's no matter. And the issue there is, again, that people in high school get educated to repeat verbatim, that mass is the quantity of matter or a measure of the quantity of matter. It turns out that a black hole has no matter whatsoever, and yet it has mass. It's got infinite mass almost, it's got all the mass you want to put in there, whatever the star had at the beginning, whatever it collected. So it's got more than 0 mass, but it's got 0 matter. And so if mass is a measure of the quantity of matter, a black hole should have 0 mass. And yet here they talk about all this mass that moves stars around, that sucks their skin, their gaseous skin into the black hole, which is the picture that you saw a minute ago. And they say all this happens because of mass, but a black hole has no matter because all of it has been crushed out of existence. You figure it out. See if it makes any sense to you. Okay, are we going to stop there? Now we have a little more informal, but still popular version here. This is from space.com, and that one comes usually from writers who essentially translate some of the papers that the mathematicians write that are unintelligible for the public. And so these guys kind of translate it and bring it down to the level of the human mind, the normal human mind. Okay, and so here's what the space.com said. This is in 2004. As to what lies in the region between a singularity, what is a singularity? A location in the center of an event horizon, which is a spherical region that covers the center that's in that's in this volume. Okay, between a singularity and its event horizon, physicists have always drawn a blank. Yeah, more or less a blank like what is there, that's a blank too. Okay, there's nothing there. Physicists have always drawn a blank, literally, yeah. No matter what type of material formed the singularity originally, right? The area inside the event horizon, or the volume, right, was supposed to be devoid of any structure or measurable characteristics. There is nothing inside a black hole. A black hole is 0-dimensional, no matter whatsoever. There is nothing there so far, according to physics. Okay? I don't care what the mathematicians say. There's nothing inside a black hole, and a black hole is made of nothing. Literally. Blank. Just like this guy said. Okay, so here's the $1 million question for you to ponder. Okay, $1 million question. Is a black hole 0D? If it is, then does it qualify as a figure? Because if it's 0-dimensional, it crushed all matter out of existence. There's no body there. There's no shape. Then what the hell do we have in front of us? Is it a geometric figure? Can we replace that nothingness with a point and say with a dot, right? And call it a point. It's a point. Well, what is a point? Well, a point, is it the dot or is it the location? If it's just a location, so far we have nothing in there. You got to tell me what's in the location. And what they're saying is what you have in the location is a location. That's what you have. And they can pinpoint it with the coordinates, right? Whatever they, as they call them, number lines. And what's in there in that location? Absolutely nothing. All it has is runaway mass. What does that mean? Well, I don't care, because I need to have a physical object to show how that center of nothing influences a star that is gazillions of miles away. That's what we need to figure out. We need to figure out the mechanism. We don't care about their math. We don't care about their mass. What we want is a mechanism. For that, you need objects. And so far, we have no object in front of us, because they tell you in your face that matter has been crushed out of existence. What the hell are we talking about as far as a black hole, about this so-called entity, this so-called geometric figure represented by a point? We have nothing in front of us. And when they say, well, you know, you're not supposed to take the analogy literally, well, I haven't understood your mechanism. Sorry. You know, and it doesn't mean that I have to take a course in math, algebra, calculus, or whatever to understand what you're saying. You know, you should be able to tell me, like Einstein said, if you can't explain it to, you know, a barmaid, then you don't know it well enough. Okay, and so what's one of the biggest problem? And here you see it. Two concepts do not make an object. It's the other way around. Two objects make a concept. Concept is a relation between at least two objects. That's what a concept is. That's the definition of the word concept. A relation between two concepts, or a word that invokes at least two objects. You need two objects to come up with any concept, because a concept is a relation. But you cannot put two concepts and make an object. I cannot take intelligence and love, put them together, and come up with a rock. And that's the big problem here. Here you have a location, which is the center of whatever. It's the center of the event horizon. What is the event horizon? It's the perimeter of the center. So it's like a circular definition. We have a point in the center, which is a location, and it's surrounded by a concept called the event horizon, which is what? A region of influence. So we have two concepts, and so far we have no object. And again, two concepts do not an object make. Conclusions. Here we go. This is what you can take home with you to the bank. Okay, you can put your hand in the fire for this. Geometry was misconceived from the start. Point, line, plane, all that stuff, misconceived. That's why they can't define it even to this day. They just tell you, we cannot define these terms. They're undefinable terms, or primitive terms, or whatever they say, you know. They cannot define these terms because you don't define objects. In physics, in science, you point to them. They should be able to point to a point to a line, point to a circle or any plane, and not have to define it. Now, plane is a category, but certainly line and point are not. Line and point are two-dimensional figures. One is a 2D circle, maybe a dot, right? And the other one is an extended rectangle, which is the so-called stick, called line. That's what we have objectively in front of us. Okay, anything more than that is in your tiny mind, not in mine. Okay, all I see in front of me is a stick, and the other one is a little dot, a circle. That's what we have objectively in front of us. I don't have to read more into it than what's in front of me. If I have to read more into it than what's in front of me, then we're not talking about a geometric figure. Now we're talking about a concept. Now you're asking me to make believe. You're asking me to be a mime and do juggling with balls that don't exist. That's what you're asking me to do. All figures of the irrational discipline known as geometry, why is it irrational? Because it's has rotten foundations, are locations and itineraries. There is not a single figure in all of geometry today that is not a bunch of locations, meaning itineraries. They are not sticks and stones. They are itineraries and locations. Okay, and geometry is the first attempt to merge math and physics into a religion known as mathematical physics. That's why you have irrational explanations today, because they started with rotten foundations. They carried them over into mathematical physics, and today we have this so-called religion, irrational discipline called mathematical physics, which attempts to merge math with physics when one has nothing to do with the other. You can do math over here. I mean, I did a lot of math in my life, but it's got nothing to do with a physical aspect, which is what people want to know out there, which is mechanisms. They want to know how Mother Nature does gravity, how Mother Nature does light, how Mother Nature does electricity. That's what people want to know. And then they're done with physics. They don't want to have anything more to do with physics once they understand why they get a shock when they put their fingers, in a socket. Mathematical physics is casually equated with science. That's the problem today. Mathematical physics is not science under any circumstance. We need rational explanations to do science. Irrational explanations We had a lot of them with traditional religions. All we have now with math phys is just a new type of a religion. That's all it is. And the priests are known as mathematicians. We call them mathemagicians. And the black hole of mathematical physics is consistent with the irrational evolution of geometry. Remember, mathematical physics really starts around the time of Newton, maybe a little earlier, maybe 100 years earlier or so. That's when it really takes strength, and gets all this energy behind it. Until then, it was just more, everybody would study geometry and then, do measurements, calculations, all based on geometry. Then when you get into Newton's days, now you get more sophisticated algebra and geometry and calculus and so on. And now this thing takes off and people think that they're going to figure out the invisible entities that Mother Nature uses out there to do her stuff. They associate it with mathematical physics. They say, oh, we're going to figure this out through math, through equations, through measurement. And it turns out these are invisible, intangible entities. You're not going to figure them out with any equation. An equation has no power to give you any information about the nature of the physical entity that underlies all these mechanisms. Okay? And then, like all other figures, it is not a figure. Okay? They have no figures in geometry, and so black hole is not a figure. A black hole is a location that moves stars around and sucks their gases, and we have no idea how a black hole does it.